Our last session, as I said, the theme is COVID-19 and climate change mitigation and adaptation. We have a great set of panelists and a moderator today. My name is Colleen Naughton. I'm an assistant professor in civil and environmental engineering and a co-principal investigator on this National Science Foundation conference grant. This is our last session, so I just want to thank, in addition, we've, as you've seen, myself and Dr. Maya Trotz, but to our organizing committee. Heather Hopkins is a program coordinator for Strong Coast at University of South Florida. Our students, Mistel Houghton and Ashley Osler, are students at University of South Florida, and Brooklyn James is a student at environmental engineering student at UC Merced. And also thank you to our sign language interpreters and closed captioners for all their work during all of these sessions.
The Association of Environmental Engineering and Science Professors, AESP, is made up of professors in academic programs throughout the world who provide education in the sciences and technologies of environmental protection.
As hard as we work in our domain expertise, we need to work equally as hard to build positive human relationships with our colleagues, our students, and the communities that we serve.
We will continue to work towards a more just, equitable, and healthy society.
The goal of the virtual conference, Converging COVID-19, Environment, Health, and Equity, is to bring together different disciplines of environmental engineering and science to discuss actions to form a more healthy, just, and equitable society.
The conference themes align with the National Academy of Science, Engineering, and Medicine's grand challenges for environmental engineering in the 21st century. And they are
COVID-19, systemic biases, and environmental engineering and education.
COVID-19, fostering informed decisions and actions.
COVID-19 and the creation of efficient, healthy, and resilient cities.
COVID-19 and sustainably supplying food, water, and energy.
COVID-19 and designing a future without pollution and waste.
COVID-19 and climate change mitigation and adaptation.
Each session, as much as possible, will look at the convergence of air,
water,
wastewater,
food,
people, the built environment,
waste, fostered by the COVID-19 pandemic, and the unfolding realities of the need to address inequities in our communities.
Faculty from the University of South Florida and the University of California, Merced, are pleased to hold this virtual conference with support from AESP and the National Science Foundation's CBET program.
It is my honor now to present the moderator for today's session, Dr. Lilia Abram. She is CEO, President, and founder of Peer Consultants. She is a trailblazer, a history maker, and an entrepreneur. She is the first African-American woman in the nation to earn a PhD in chemical engineering, the first African-American to start an engineering consulting firm focused on environment and environmental issues. Dr. Abram is a National Academy of Engineering member, NAE member. She is president-elect of the American Academy of Environmental Engineering and Scientists, AAES, and she's an AWSP Legacy member. So please join me in welcoming our moderator, Dr. Abram.
Good morning, Dr. Naughton. Thank you very much for that very kind and grandiose introduction. Thank you all for meeting us here today for the 6th of the 6 sessions. And this one is on COVID-19, climate change mitigation and adaptation. Our panelists today will be presenting cogent ideas and perspectives on climate change and mitigation in a world where, honestly, we are beyond being able to mitigate climate change. The Earth is getting hotter, and humans on this planet are largely to blame. We should not abandon the strategies that will help curb climate change, such as energy efficiency, advancing alternative energy sources, advancing climate intervention strategies, and reducing greenhouse gases, as described in the report that this workshop is based on. But we should also begin to think strategically about mass migrations to the U.S. interiors because of climate change, using system thinking approaches to identify potential outcomes and solutions in real time. I think mass migrations to the interior of the U.S. have already begun. And while initially they were not climate change driven, climate change is now becoming the major driver. These migrations must be anticipated, understood, and planned for. I am the product of the outcome of already 2 mass migrations. One, not desired, but it happened, and that is the forced migration of the Africans from the African continent, starting in the early 1600s and before. This mass migration resulted in a fourth of the population of the African continent being transported all over the world. The unintended consequences of that migration are still being resolved to this day. The second mass migration, termed the Great Migration, was the self-imposed relocation of more than 6 million African Americans from the rural South to the U.S. cities of the North, Midwest, and West from about 1916 to 1979. The unintended consequences of that migration are major reasons for the continuing civil and political upheaval in the U.S. today. President Obama, in a 2016 presidential memorandum, Climate Change and National Security, pointed out that the relationship between climate change and migration, with unintended consequences of political and civil instability. He directed federal agencies to perform certain functions to ensure that climate change-related impacts are fully considered in the development of national security doctrine, plans, and policies. By breaking climate change down into its component geophysical symptoms, the memo makes a strong case for treating it as a threat multiplier, with the potential to push vulnerable states past the tipping point into chaos. Extended drought, more frequent and severe weather events, heat waves, warming and acidifying ocean waters, catastrophic wildfires, and rising sea levels all have compounding effects on people's health and well-being. Flooding and water scarcity can negatively affect food and energy production. Energy infrastructure, essential for supporting other key sectors, is already vulnerable to extreme weather and may be further compromised. Other concerns are transportation disruptions, pest outbreaks, the spread of invasive species, and disease. All of these can lead to population migration within and across borders, spur crises, and amplify or accelerate conflict in countries or regions already facing instability and fragility. The mass migration in the U.S. to its north, south, east, and west close by interiors has begun. And it is incumbent upon environmental engineers to put themselves clearly on the forefront of developing and implementing strategies to adapt to climate change in place and to work collaboratively in multidisciplinary teams utilizing system thinking approaches to provide solutions to responding to a changing planet caused by a changing climate. Now let's turn our attention to our sixth session, COVID-19 and climate change mitigation and adaptation. Our first speaker, Dr. Sybil Derable. Dr. Sybil Derable is an associate professor of civil and materials engineering in the University of Illinois, Chicago, College of Engineering, and a research associate professor at the Institute for Environmental Science and Policy at UIC. He is the co-author of a recent book, Urban Infrastructure, Reflections for 2100. Dr. Derable.
Hello. Thank you very much, Dr. Abe. I have goosebumps. Your speech was amazing. Thank you very much. What I'll do now is I'll tell you a little bit about a project that we've had with UIC and Arizona State University since April, and it's about surveying people in the United States about how they've been affected to COVID-19 with a focus on travel behavior. We're all transportation people, so we're not medical people, but we're asking them about their habits, how they've changed, and their attitudes, how they have changed. Next slide, please. So you can learn more, by the way, you can learn more at covidfuture.org. The survey includes 7 sections: employment, working and studying, shopping and dining, daily transport, attitudes, demographics, and social network. We've done an extensive work. We have close to 9,000 responses. We're planning on having 3 waves. So we've completed wave 1, and now we want to see whether the changes that were measured in wave 1 persist over time. People keep adapting their behavior, and we want to see what persists and what does not persist. We've just finished the collection of the data. Unfortunately, we have not analyzed data thoroughly. So I'll present to you some really overall trends that we've seen, but there's much more in the data itself. We'll do some analysis ourselves, but the data will also be made completely available to everyone. It is part of, we have received funding from the United States National Science Foundation and from the US Department of Transportation. So all the data will be released. You will all have access to it. But so right now, the insights are very limited. I apologize in advance. And next slide, please. The first thing that we'll see is that long distance air travel is being impacted severely. Right now, of course, not many people are using it, but even in the future, with how easy it is to use Zoom, what we're doing now, a lot of people think that they won't travel as much in the future. So that's probably the biggest sector that has been affected. Next slide, please. The second one is about the working from home. So the one on the figure on the left shows before the pandemic. You can see a big spike around 5, which is the number of times that people commute per week. So it was, 5 was noticeably the largest one before the pandemic. And during the pandemic, a large proportion of those 5 days per week has switched to 0. So a lot of people commute. A lot of people don't commute anymore. They just work from home. Next slide, please. And when we look at who has the ability to work from home and who doesn't, what we can see is, so you can see on the 2 panels on the left-hand side are others, and the 2 on the right-hand side are low-income households. And we have before and after. And what we see is that for low-income households, the proportion of households who have been able to switch from working in place at their work to working from home is not as much, which means that people with low income households they can't work from home. A lot of them have to still go to their jobs, and so they are at a high risk of getting COVID-19. Next slide, please. And there's a direct relationship between low income and low education, and that's what we see here. So the more you go towards the right on the figure, the less educated the people are. And what we see is the lighter green and darker green. Lighter green are not having work from home option, and darker green are having work from home option. So the higher your degree, the more you're able to work from home. The less education, the less your options to work from home. So these are the big some of the big insights that we found. Next slide, please. In terms of commute, in terms of travel mode to commute, what we found is that, so on the left-hand side here, we see the pre-COVID-19 case, and the right-hand side is the during COVID-19 case. Private vehicle has always been the largest mode of travel to go to work. Now, during COVID-19, just a lot of those commutes, trips just don't happen anymore. People see that transit has been affected quite severely. A lot of people used to take transit to go to work, and it's just not happening as much now. In that case here from the figure, we see that in large part because people are just not commuting anymore. And if we can go to the next slide, that's gonna be my last slide. It's about attitudes and risk perception. And so people do feel in the United States that riding public transportation is a high risk. And I like to emphasize that this is really from the United States. I'm actually French. I was during the whole stay-at-home order in the spring, I was in France. People were still using some public transit. People were wearing masks. They were washing their hands. As far as I know, in many countries in the world, public transit ridership has gone up to pre-COVID-19 levels. So this is really a US thing. But so riding public transportation is really seen as not safe, as well as taking an airplane. Next slide, please. So this is really basic trends that we've identified. I'm sure you expected them. We are analyzing the data as they come in. We hope to have more and more data for you soon. The data will be available at covidfuture.org, and you can take our survey at covidfuture.org. We do ask a lot of questions. The survey does take about 20 minutes. We had a lot of questions about the impact of education. We've seen that. There's about gender, there's about race and ethnicity. So there's definitely a lot of work to be done, and I look forward to doing it and sharing it with many of you in the future. The last thing I want to say is that we did have a 2-hour session yesterday about some of the results, and I have the video recording. So I'll put the link in the chat, and you're more than welcome to watch it if you want to. And of course, I'll stay around if you have any questions after all the speakers have presented. Thank you very much.
Thank you very much, Dr. Darable. And now our next speaker is Dr. Richard L. Corsi. Dr. Corsi is the Dean of Portland State University's Massey College of Engineering and Computer Science. He has over 25 years prior to his current position as professor, department chair, and endowed chair in the Department of Civil, Architectural, and Environmental Engineering at the University of Texas at Austin. He is the president of the Academy of Fellows of the International Society of Indoor Air Quality and Climate. Dr. Corsi.
Thank you, Lilia. Slide, thank you. So I'm going to speak about indoor air quality, climate adaptation, and environmental justice, or more specifically, equity. I think everybody realizes we're in the middle of two huge crises at the moment, two big challenges, a horrific pandemic, and the ravages of climate change continue. Out west, we've been seeing historic wildfires that have an undue impact on underserved communities. What we need to do to deal with these events are sometimes contradictory. So for COVID-19, we're told we should have greater ventilation in schools, greater ventilation in our homes, greater ventilations everywhere. For wildfires, we're told to have less ventilation in schools, less ventilation at home, less ventilation everywhere. And so we have these sort of contradictory things we have to do to deal with each of these crises at the same time. And how we do these, and we can deal with both of those things, but there are real equity issues because of the cost of trying to deal with both of those things simultaneously. So I'm going to talk about that in my next few slides. Next slide, please. So underserved communities, they struggle with both of these issues, right? We have multi-generational families in many underserved communities that live in smaller homes, so they're more prone to rapid spread of COVID-19 infection in the household. They lack money for effective controls in the home to control aerosol particles in the air, for example. They may have less quality health care. As Sybil said, many in underserved communities can't work from home, and so they have to go to work. They work in service jobs. There's been a huge job loss in the service industry, and even if they keep their job, the service industry tends to be very lacking in controls for things like aerosol particles. And then if we look at schools, most in underserved communities go to public schools. We saw yesterday that New York City closed all of their public schools, and most of the private schools are staying open. And the private schools can stay open because they're less dense, there's less children in the classroom, they have a lot more money, they can spend money on control technologies to improve the environment for COVID-19. And public schools don't have that money, don't have those controls, and so they have greater infection risks for the students as well as teachers and staff. Next slide. So I'm going to talk about, in my next 3 slides, one technology that actually can deal with both the effects of COVID-19, reducing our dose and therefore risk to associate with aerosol particles that are virus laden, but also can help us deal with particles associated with wildfire smoke, which can be quite harmful, especially to people that have respiratory diseases like asthma. HEPA air cleaners, high efficiency particulate air filters, are a proven technology. They are a great supplement to ventilation when we want to ventilate less. They can give you sort of the equivalent, if used appropriately for a good portable air cleaner, up to 3 or 4 air changes per hour, which is much greater than you typically find on average in an American home. They're valuable in wildfire season. So my wife and I had 2 really good portable air cleaners in our house during extreme wildfire season in Oregon, and they work wonders for us in terms of dramatically lowering particle levels in our home. Significant dose reduction for virus-laden particles that carry the SARS-CoV-2 virus. The problem with them is that they're cost prohibitive for many. So good portable air cleaners like a HEPA portable air cleaner that treats a large space can run you $250, $300. And if you wanted to have multiples of those in a home or one in every classroom in a school, you're running up in the hundreds to thousands to $10,000s of dollars. Next slide, please. So what's happened is there's been some, and this is really exciting for me, is that there's been some really bright individuals who have said, let's solve this problem by making our own portable air cleaners. What if we took a $17 box fan and we purchased a good filter, a MERV 12 or a MERV 13 filter, and we put it up against the box fan and we sucked through the filter as opposed to trying to push through the filter, because if we suck through the filter, it'll seal nicely to the box fan. Can we use that to actually reduce aerosol particles inside schools or homes? Aerosol particles that might be associated with wildfire smoke or might be associated with virus-laden particles that contain the SARS-CoV-2 virus. And these are just results from a very simple test done by one of our new assistant professors at Portland State University, showing on the vertical axis the fine particulate matter concentration in micrograms per cubic meter in a small room in his home versus minutes from when the fan was turned on. And he was running at about 160 micrograms per cubic meter in his house. He used this in a room in his house, and you can see this dramatic reduction in particulate matter from literally a device that cost him about $35 to build, with a MERV 13 filter and a box fan. The problem with doing this is that there's a pretty big resistance in trying to get the flow from a box fan to go through a filter. And so on social media, I threw out the idea that maybe we should actually build the unit, build an actual portable air cleaner where the walls of the portable air cleaner were MERV 13 filters, so that we could dramatically reduce the resistance through the unit and get a higher airflow. And so, next slide, please. And so a wonderful tinkerer and innovator in Texas built what you see on the left, which he called the Corsi box, which I shouldn't have taken credit for because he built it within 24 hours of hearing this. And he built this beautiful portable air cleaner where the walls of the air cleaner are actually MERV 13 filters, dramatically reduces the resistance on the fan, and so you can get a much higher flow through it. And the unit that you see here is almost as effective as one of these $250 to $300 fancy portable air cleaners at a fraction of the cost, about a sixth to a seventh of the cost. So one idea here is it possible to get organizations to assist with teaching people, maybe teaching high school students, how to make or to mass produce these low-cost portable air cleaners for schools and homes in underserved communities. So coining the term here, citizen manufacturing, as a way of dealing with two crises at once, the ravages of smoke from wildfires and also the ravages of virus-laden particles in homes and schools associated with COVID-19. Can we deal with both of those and serve underserved communities with these new portable air cleaners that are much lower cost? So I just throwing that out there as an idea for our community and hoping that some people are interested in it. So thank you.
Thank you, Dr. Corsi. Very interesting. Our next speaker is Dr. Marcus Hendricks. Dr. Hendricks is an assistant professor in the School of Architecture, Planning, and Preservation at the University of Maryland. He is also the director of the SIRJ lab and an affiliated research faculty in the Clark School of Engineering Center for Disaster Resilience. Dr. Hendricks.
Thank you so much, Dr. Abram. And I first, I want to sort of take a moment to sort of give you flowers verbally for two reasons. One, for the wonderful introduction, and for two, for being a trailblazer for folks that look like you and I, to be in this position and to be doing the work that you've done and that I'm starting to do. And I don't take that lightly, and I sincerely appreciate it and want to take the moment to say that. As Dr. Abrams said, my name is Dr. Marcus Hendricks. I'm currently an assistant professor of urban studies and planning at the University of Maryland. I also direct a lab by the name of the Stormwater Infrastructure Resilience and Justice Lab. I also want to thank AEESP for allowing me to share this space with you all today as a planner and a social scientist by training, and to be able to share my thoughts and research. Next slide, please. And so this is probably the last group that I have to convince that we're in the middle of an infrastructure crisis, from collapsing bridges in California to overflowing storm drains in Houston. Infrastructure systems are far past their prime, and decaying infrastructures all around us, including public hospitals, where we've seen, have serviced, marginalized communities and disproportionately have suffered relative to white groups and other groups that have had better service and treatment. The American Society of Civil Engineers has consistently sort of scored our nation's infrastructure from the local level up at a D+. And this infrastructure crisis has been well documented, both in media and a start in the research. Next slide, please. In fact, this summer, I took a moment to further document this infrastructure crisis and to make a connection between the current coronavirus pandemic and our infrastructure crisis by discussing sanitary sewer overflows and backups in the city of Baltimore and a potential risk of COVID transmission by way of wastewater exposure. Next slide, please. However, for anybody that studies any type of disaster or crisis, we know that social stratification is inherent. However, no attention has been paid to where and on whom the burdens of this decaying infrastructure or this infrastructure crisis fall heaviest. Next slide, please. And so I want to turn us to sort of a series of social phenomena and events that have transpired since, as Dr. Abrams said, from 1619 and beyond, in terms of the Black American experience, from slavery to Jim Crow, through segregation and redlining, through the civil rights era, to even, subprime mortgage loans, and how Black and brown households were disproportionately affected in 2008 during the Great Recession. Next slide, please. These social processes, from poverty to discriminatory planning to ongoing economic disinvestment and segregation and redlining and racial zoning, are inextricably linked to these infrastructural processes in terms of the inventory, condition, distribution of physical infrastructure systems, and even the maintenance and rehabilitation decisions and processes that we make in terms of investments through capital improvement programs. However, most often, folks who have been involved in the space of infrastructure management and a built environment haven't necessarily made this connection between these social and infrastructural processes. Next slide, please. But I want to offer sort of two frameworks that I work within between environmental justice and social vulnerability to disaster that offers us perspective by which we may sort of examine the connection between social processes and infrastructure processes. Environmental justice talks about how the nation's environmental laws, regulations, policies have not been fairly applied across all segments of the population. When it comes to social vulnerability to disaster, social stratification based on race, income, disability, gender, age, nationality, among other social characteristics, contribute to differential risk and impacts from disasters. And I also want to pause here parenthetically to say, to be clear, that although most often when we map and model issues around vulnerability and environmental justice, we reduce it to, race, income, and class labels. But these are fundamentally issues of racism, classism, sexism, and I want to be very clear about that. Next slide. And so some selected mentions from the environmental justice and social vulnerability literatures. Dr. Robert Bullard in 1994 charged the nation to redefine environment to include infrastructure. My colleague, Dr. Sakobi Wilson here at the University of Maryland in 2008 talked about the failure of municipalities to install up-to-code sewer and water infrastructure can lead to vulnerabilities in sewer and water systems, particularly among poor people and people of color. Dr. Shannon Van Zandt in 2012 started to allude to how infrastructure and other environmental features can potentially modify vulnerabilities and exacerbate risk. And some of my early work in participatory planning, I discuss how through participation and community science provision of infrastructure, there's an opportunity for us to redistribute public resources towards justice and sustainability. Next slide, please. And so through my Stormwater Infrastructure Resilience and Justice Lab at the University of Maryland, me and my research team do just that. We talk about the nexus of environmental planning, infrastructure planning, participation, and hazard mitigation and disaster recovery planning to think about the effects of infrastructure on a natural, built, and social environment. We also explore the role of infrastructure in modifying hazard and climate-related risk and even public health outcomes. We think about infrastructure design and resilience and adaptation and how we might change the way that we do business, both from a social management perspective as well as a physical design perspective in light of sustainability. I also talk a lot about, how can we mobilize and activate community and citizen groups to be involved in overseeing and provisioning infrastructure. And last and certainly not least, the foundation of my research program and the work out of my lab is to understand and address equity and environmental justice issues related to infrastructure and public works, particularly in terms of processes, distribution, and restorative justice. Next slide, please. And so just to take you all really quickly through some empirical work that I've done, across the country between Houston and Washington, D.C., I've been able to show that, particularly when it comes to stormwater infrastructure systems, that communities of color and lower incomes income communities in Houston have stormwater systems that are past their prime and outdated by development codes and just frankly not desirable by the community. And also the burden of maintaining some of these stormwater systems that are disproportionately located in communities of color falls on the community themselves, as opposed to the city of Houston taking responsibility. And above and beyond sort of the neighborhood level factors that we might assume drive the distribution of physical systems, the percent non-Hispanic Black above and beyond was the most significant predictor of the distribution of these outdated systems. Next slide. Some of my other work in terms of mobilizing community students, their parents and teachers on the east end of inner city Houston, I developed a participatory assessment technique for infrastructure to be able to think about how can we engage community members for taking ownership over these systems and working with cities in order to effectively manage these systems. But most often I know not only are these communities overburdened by environmental bads and locally unwanted land uses, but they also struggle with the burden of proof in terms of being able to, empirically demonstrate, in fact, that they're experiencing these things. And so immediately after I developed this participatory assessment technique, I took it a step further and developed an experiment alongside some of my engineering colleagues at Texas A&M to where we sort of we set up an experiment by which community scientists, trained engineers, and LiDAR technology inspected the same set of infrastructure assets, and we were able to empirically show that there wasn't a statistically significant difference in the quality of data between citizen scientists, trained inspectors, and LiDAR technology in terms of validity and reliability. Next slide, please. And lastly, one of my more recent publications really just shows how, we have to sort of envision a future by which, municipalities, universities partner with communities to design grassroots master plans that include infrastructure interventions that address a number of issues from sustainability to climate change and flood risk. And these sort of grassroots master plans is just sort of the first step of leveling the landscape for these communities who have been marginalized over time. Next slide, please. And so, the main takeaways for my presentation is really sort of charging you all to think about equity and infrastructure in terms of procedural, distributive, and restorative justice. And also thinking about sort of the built environment or in terms of stormwater or public health infrastructure must be recognized as a continuation of social circumstances in terms of these larger social processes that moderate outcomes related to infrastructure. And lastly, the future is hopefully more democratic and democracy is alive and well. And the more folks that we have participating in processes related to infrastructure and beyond is critical through community science and civic participation and different types of partnerships that are fundamental to equity and resilience. Next slide, please. And I always just like to end on this slide. This picture is a picture of me and a group of Black and brown students on the east end of inner city Houston, who I dedicated my dissertation research to, and I really believe that they're the vanguard of the environmental justice movement moving forward. And I owe sort of all of my early work and my entire career to them in terms of really sharing with me their knowledge and intuition around a number of these critical issues. Thank you all so much.
Thank you, Dr. Hendricks. Our next speaker is Dr. Shannon Capps. Dr. Capps is an assistant professor of civil, architectural, and environmental engineering at Drexel University. Dr. Capps leads the atmospheric modeling at Drexel Group, which conducts outdoor air quality modeling to estimate influences of emission sources, evaluate health, ecosystem, and climate impacts of pollutants, and assimilate satellite-based observations to improve models. Dr. Capps.
Thank you, Dr. Abram. We've heard today about how transportation habits have changed for people during COVID-19. And I want to introduce the process by which we ask this question. Do pictures of air pollution from space actually reflect those changes in US cities? Next slide, please. So we take pictures of air pollution from space with special cameras like the Trope-OMI instrument. These fly around the world every day and provide a picture with pixel sizes in the image of about 3 kilometers by 5 kilometers. So they're high enough resolution to tell the difference in concentrations of pollutants across cities and within them. We use this instrument because it measures the concentration of nitrogen dioxide between the satellite and the ground over which it's looking. One thing that happens in between that space is that cars are driving along, burning fossil fuels, and creating emissions of oxides of nitrogen. These change chemically in the air to form nitrogen dioxide, and we can get pictures of that with satellites. You might have seen some of these images early in the pandemic in late March and early April, where changes from a couple of weeks before to the weeks where people were in lockdown reflected significant drops in the concentration of air pollutants. But the question we wanted to ask was whether those were reflective primarily of driving patterns or might not be attributable to that. In order to answer that question, we focused on 10 US cities, specifically the combined statistical area around cities. This encompasses where people are driving from into urban areas for work. So it's quite relevant to this question of equity when people are driving in from suburbs into dense traffic in cities. The people most exposed to that pollution would be those who are dwelling there. So there are interesting questions about equity that we're asking here. I'm focusing the results in this talk today on nitrogen dioxide concentrations in 2 cities, New York and Dallas-Fort Worth. But I should note that not only is nitrogen dioxide made when you drive a car, also carbon dioxide is made. And that is a contributor to greenhouse warming. And so this is the way that we can have some intersection of this work with climate change. Next slide, please. You'll see here results from those 2 cities, Dallas and New York City. These are time series of the column concentrations of nitrogen dioxide on a weekly average over those 2 areas. What we were surprised by was how large the differences are from week to week in the average in both Dallas and New York when we looked at only that purple line. That's for 2020. That caused us to go back and ask, are these changes just due to meteorology and other sources changing? Or are the drops that we see in the purple time series around late March and early April actually reflective of changes with behavior during COVID? When we saw that the magnitude of the change was similar from the satellite-based pictures in 2019, we thought we should take a more careful look at the NO2 concentrations that are measured locally. Next slide, please. Here we have the daily maximum of the NO2 concentration measured at specific locations in these cities by the Environmental Protection Agency's monitors that are always operating. You can see that the changes from day to day are more significant. Anything above the black line means that it is a an increase from the 2019 levels to 2020. Anything below the black line would be a decrease. We see a decrease, as we expected, in Dallas around late March in both the satellite, the blue line, and the locally observed changes, the red line. Likewise, in New York, there's actually a longer but smaller percentage-wise depression of these concentrations. And what this told us is that we can have some confidence in the satellite-based observations of changes in NO2 concentrations, even at these city scales. Next slide, please. Why we wanted to look at different cities is because these oxides of nitrogen are produced by different sources, not only cars and trucks, though cars and trucks make up the largest percent in each of these cities, as shown with the blue portion of each of the bars. But if you look at the different bars, the fuel combustion, perhaps for heating, or industrial processing sector when chemical components are being made by burning fossil fuels, those also contribute to oxides of nitrogen being emitted. If you'll focus on Dallas, which is noted with DAL, you can see that it has a much larger blue bar than New York City does. This means if one person in New York stops driving, they would have a smaller impact on the NO2 concentration than a person who stops driving in Dallas. Next slide, please. Knowing that, we wanted to take a look at the measures of behavior that are accessible in the entire US. And those are people staying at home based on Google's mobile data. So these are people whose cell phones remain in the same place for 24 hours. That's shown in the orange line. And we can see a tremendous increase from the early 2020 levels in late March and April in both Dallas and New York, though the increase is a bit larger in New York City than it is in Dallas percentage-wise. The green line indicates those who have ceased to request driving directions from Apple Maps. And that's a similar indicator. When it is negative, it is indicating that we would expect fewer emissions of NOx from mobile sources. So we have fewer percentage-wise people staying home in Dallas, but a similar approximate change in driving directions. Next slide, please. Putting together these changes in behavior with the changes observed in concentration and thinking about the fact that one person who stops driving in Dallas will have a bigger impact on the NO2 concentration, we can see exactly what we expect. We have a larger decrease in the NO2 concentrations in Dallas, even though somewhat fewer people stop driving. Then we observe simultaneously in New York when more people started staying home in late March. So this is indicative to us that we can actually tell not only about the concentration, but if we parse through the details well enough, we can see that from space, we're able to observe what kinds of transportation people are choosing. A practical impact would be perhaps you've learned to ride a bike during COVID or found a great walking path to some things that you are still able to do outside the home. Those things done at scale, so 20 to 30% of the city employing walking or biking instead of driving, would have an impact that would be visible from space on air pollution in cities. Thanks so much for the opportunity to share this work. Please feel free to contact me with further questions.
Thank you so very much, Dr. Capps. Very interesting. Our last speaker is my next president-to-be in the American Academy, Dr. Dan Other. Dr. Other is a professor of civil, architectural, and environmental engineering at Missouri University of Science and Technology. He is an American science diplomat, social entrepreneur, and professor of environmental health engineering. He is Vice President of the American Academy of Environmental Engineers and Scientists. Dr. Other.
Dr. Abram, thank you so much for that kind introduction. I really appreciate it. And I really appreciated your remarks to open this session. As being the last speaker, my slides are perhaps maybe a little less detailed, and I'm trying to leave you with perhaps maybe a broader view of next things we might undertake. And this is going to be a little bit different talk for environmental engineers and scientists. I'm talking about how do we use insurance to promote community resilience. Now, my slides are posted on my Twitter feed. So for those of you that like to actually see the slides or have copies, the JPEGs are up on Twitter. So just hop over and look at that Twitter handle of it at Daniel Other. And I'd love for you to comment and make some points there as well. On the next slide, we're going to see the actual objectives of this presentation. There we go. So there's 3 learning objectives. I'm trying to get you to leave here learning 3 things. Number 1, sustainable development includes more than meeting immediate physiological needs. Much of what we do in environmental engineering and science is around meeting immediate physiological needs, access to clean water, access to toilets, access to clean food, right? These are the things that we've historically done. But sustainable development, what we're doing at the United Nations between now and 2030 means more than that. And we're going to get into that in a second. Also, environmental engineering, particularly in a world that's thinking about adapting to a changing weather patterns, to a changing climate, means that we need to become part and parcel of this idea of building back better. The world needs to be built in a way to address what the future looks like. We need to be imagining that, our kids right now going to school are going to retire into a world of 2065, 2075, right? So the things we're building now have to be able to exist into that world that we have a difficult time even imagining. And so that means that we need to design systems to come back better. Also, and as I think this is a theme throughout this entire meeting, but especially in this particular panel, the way we teach and practice and the way we engage with policy and environmental engineering must truly leverage convergence. And I'm going to get into this at the end of my talk about what that means to me and why I think that's important. So on the next slide, we're going to see kind of, the background that motivates this. Now, I think all of us in environmental engineering have seen this definition from our common future. What is sustainable development? Well, it's meeting the needs of the present without compromising the ability of future generations to meet their own needs. And I would suggest to you that many of the times when we talk about this definition, we talk about the timeliness of it. We talk about the consumptiveness of it. Let's not be gluttonous because this is good for our children and our grandchildren. Let's not overconsume. And those are certainly important things to come out of this, but I'm going to have us key on the word needs. What's a need? Is a second pair of tennis shoes a need? Is a raincoat on top of a winter coat a need? What do we mean by needs? So when we turn to Maslow's hierarchy of needs, a great tool from motivational research to understand, what do people need? Well, the bottom rung is the physiological needs. People need food and they need water. And we understand that as environmental engineers and scientists. We work on providing that to people. But oftentimes we stop there. And so we kind of operate in this world of the have and have nots. There's those that we've helped with physiological needs and those we haven't helped. And so we do things that help get people access to meeting those needs. But I would actually posit or argue that more than that is we need to look up the pyramid. We have the ability to contribute to safety and security, to love and fellowship, to esteem, right? We have the ability to contribute in more than just meeting the physiological needs. And this is where the sustainable development goals, this on the lower right panel, these 17 goals that the world is doing between now and 2030 become so important. So if you're not familiar with them, I urge you to become familiar with them. Yes, it's about getting water filters to folks and it's about improving water systems, but it's about making those systems be secure so that they continue to deliver water even when there is a drought. And you notice I didn't say if there was a drought, I said when there's a drought. So we look at the next slide. Development. Between now and 2030, between now and 2050, forever, development is always interrupted by disaster. This is shown here by this circle on the left-hand side. We have a response to a horrible disaster. We end up recovering from it in some way. And then as we go forward with development, we try to mitigate what would be future disasters. We try to prepare for future disasters. So we used past experiences with SARJ to be able to prepare for this current experience. We're right now rushing a vaccine out based on past experience, which will make us be able to recover better in the future. And certainly technology contributes to that, but financial systems contribute to that. So this is the gecko from Geico, right? We all know that. Do you have insurance? Well, insurance is one of those financial instruments that we as engineers can make contributions to. All insurance is underpinned by models. And we as engineers understand system thinking. We understand and create models. If we can create the right kind of models, we can incentivize the right kinds of behaviors. So we know that our life insurance costs less if we give up smoking. We know that our health insurance costs less if we get more exercise. Imagine if we incorporated climate resilience into insurance. What would that look like? Could we incentivize the right kind of climate behaviors because we created good models to underpin wisely developed insurance policies? So on the next slide, I'm going to say, we actually have done this in environmental engineering and science. Reduce, reuse, recycle. It's not insurance, but it is a financial instrument to nudge behaviors. The idea of a financial benefit from recycling your plastic bottle, that is a nudge behavior. That is a fantastic tool for causing people to approach the world slightly differently, and that helps. It complements, it's synergistic with our technologies. So as we'll see on the next slide, I've been working on how to help the Caribbean fisheries industry deal with the changing climate. Practically speaking, the oceans are getting warmer. There's more CO2 in them. Fish migrate in different ways. There are worse and more storms through the Caribbean. And the fishing industry is highly susceptible to those storms. So how do you convince fishers to use slightly better nets, to not drag things across a reef, to not use such small nets that they capture the little fish in addition to the mature, larger fish? How do you incentivize the behavior to move to an inboard motor versus an outboard motor, to not have as much marine pollution? Well, we've designed an insurance scheme so that fishers build back better after the damage of a storm. Now, this same tool is being applied to disease outbreaks like COVID. Now, in case of COVID, the proverbial horse is out of the barn, right? We can't make an insurance scheme for COVID because we're already living through it. But what would it look like if we used insurance schemes to help incentivize vaccine uptake? I mean, we've rushed to create a vaccine, and now the discussion is, do we or don't we really trust that it's safe to get this rushed vaccine? Both people that like vaccines and people that don't are starting to raise concerns. And we haven't thought about, how do we have an insurance scheme in there? How do we make people feel safe and secure that the vaccine is something they should go take? Because it is safe for their families, it is safe for their loved ones, right? These are the kinds of places where engineers creating models that describe risk, that communicate that risk accurately, that link finance to people, to the planet, things that we do in environmental engineering. Here's where we can make some contributions. For those of you that'd like to know more about it, on the next slide, I've got some bibliography. And here's where I think we really need to move ourselves. I've got a paper that discusses how I came up with COAST and worked on that in partnership in the Caribbean. But the three papers that, if you haven't read, I highly recommend you read are Mihalchik's 2017 paper in Environmental Engineering and Science, where he and his colleagues describe how much broader a view we need to have of environmental engineering, how much we need to return to our roots of addressing health issues more broadly. It's not that we shouldn't do lab experiments and not that we shouldn't continue to make activated sludge work a little better. It's that we have an obligation to do more. We have an opportunity to do more. And then I really like the paper by Edwards and Roy, again in Environmental Engineering and Science in 2017, that raises this specter that perhaps we're incentivizing our own field in the wrong way. And it directly plays into this recent paper by Montoya et al. In 2020. If we want people to engage in community research, if we want people to be truly convergent in environmental engineering, we must change the way we evaluate promotion and tenure. We must change the way we support faculty wanting to work in these action research areas. Last slide, please. I told you I was going to try to convince you of three kind of learning objectives here. I hope I've convinced you that sustainable development means more than just meeting our immediate physiological needs. I hope I've convinced you that environmental engineers have an obligation and opportunity to help build back better, and that's where resilience will come from. And then I hope I've convinced you that there's a lot of smart people out there that are pushing hard to say that we need to change our way that we look at teaching and practice and policy to truly leverage convergence. Thanks for your attention. I appreciate you being here.
Thank you, Professor Other. I think we're going to all come back together now for a brief session of questions and answers and discussion on what we've heard. And then I'll come back for a closing. I'm going to have moderator privilege, and I would like to, and you all can chime in however way you would like. I would like to know, in your research or in your teaching, how do you include equity? We've had some very good discussions on equity and the way we perceive it this morning. How do you include equity in the work that you do? We don't all have to rush at one time. Do I have to call on somebody? Thanks, Dan.
I'm happy to weigh in, right?
All right.
So I'll weigh in from this perspective. It's incredibly difficult for me. As a white, middle-class, middle-aged male, I've got to learn a huge amount about humility to include equity. I've got to, if I want to partner, I've got to realize that I can't be the role model. I can be an ally. I can shut up and listen. But for me to include equity, I have to be incredibly intentional about humble and listening and learning from others. And so, I think about equity the same way I do kind of cultural awareness. When I go to another country, I spend a lot of time listening and learning. And when I'm thinking about how do I, from the perspective of privilege that I've lived, how do I work with equity? I have to start with a lot of humility myself. We've got other people on the panel that will probably answer in other ways. So,
thank you. Next.
Yeah, I'll chime in.
Thanks,
I
Marcus.
appreciate that, Dan, in saying that. I think humility is, in fact, the first step in terms of addressing equity. And I think through my work in one of the papers that I mentioned, in terms of how I include equity in my pedagogy is really through service learning opportunities and partnering with communities, and exchanging ideas and information and really reframing how we think about knowledge production, and recognizing that, community folks are brilliant in their own right and have sort of an intuition that we can't necessarily anticipate from the literature or from running models or secondary data. That's incredibly important in terms of sort of understanding comprehensively the issues that we're all focused on. And so I think, through both humility as well as service learning opportunities and partnering with communities to, provide a seat at the table from the very beginning, from research question formulation through, analyzing, the data to then interpreting the findings, as well as, being able to be in front of students and being able to discuss ideas and thoughts is very critical in terms of equity, in my opinion, and how I include it in my pedagogy.
Very interesting. Anyone? Any Professor Capps?
I'll let Dr. Corsi share first since he's got his hand
Okay,
raised.
I didn't see. I'm sorry, I didn't see his hand.
That's
Dr. Corsi?
So I agree with everything that Dan and Marcus said, absolutely. I will say that when I was at the University of Texas, I had a fairly large research team. We would do lots of research, but almost all of my students, my graduate students, my PhD students, and master's students, we would do volunteer work in the community. And that was sort of expected of the graduate students. And we would work a lot with schools and underserved communities, both in Austin and in the Rio Grande Valley. And we would actually go to the schools and we would work with the schools to try to improve indoor air quality. And a couple of years ago, about 3 or 4 years ago, we rented some big vans and had students that we actually picked up students in their communities, brought them to the University of Texas and had them work in my laboratories for a week. So they actually got familiar with how to work with tools in the laboratory, and we had little projects for them to do. And then they all made presentations to groups of faculty about what they found in their research. And this was all volunteer work, and it takes a lot of time to do those things, but I think that in academia we need to try to craft that time somehow in our schedules. And at Portland State University as dean, I'm trying to impress that on our faculty to do more of those kinds of things.
Very good, thank you. Anybody else before I go to the next question?
I'll just jump in quickly. I think that's
Okay.
a wonderful example practically, and it's been delightful to have high school students work in my lab learning computer science skills from many of the underserved high schools in Philadelphia. And yeah, I think there are neat opportunities in the future that we plan to share results of modeling with a local middle school. But I would say practically it influences my educational work probably more so. We do project-based learning in fluid mechanics class for civil architectural and environmental engineers, and allowing them to choose real world projects that sometimes have these equity issues to consider, I think is a neat way to incorporate it in some of the fundamental learning that engineers are doing, as well as senior design projects. So a senior design team I'm leading is working on water, access to clean water for Haitians in Port-au-Prince. And so these would be opportunities that I think the students really have to test their understanding of design with equity as a component of it.
Thank you. I'm going to ask you all to think about how your research is more convergent, but I'd like to just throw out that equity also is how you treat your colleagues and people that you work with every day. And think about how you do that. Just a quick story. When I was in graduate school 100 years ago, we were all on public health service grants. And we would all get together at lunchtime and play whist. And I was the only female and the only African American. And the conversation would invariably sometimes get around to welfare and people on welfare and all. And I'd sit there and take it. And after a while, I couldn't take it anymore. So I just asked, I said, tell me something. And everybody said, what, Lil? I said, what color is that check you get every month? And they said, what? I said, what color is that check you get every month? Well, I don't know. I haven't looked at it. I said, well, it's green. They said, okay, what does that mean? I said, that's the same color check welfare mamas get also. And then they left that conversation alone. So you have to think, sometimes when you say things, you mean it one way, but it comes off of another. And in some ways, we're all very equal. So just kind of keep that in mind. I'd like to know from a few of you, how can you make your research more convergent? And then I'm going to open up to the floor. I've heard a lot of good answers during this discussion. Dr. Corsi?
Well, I would say that, convergent research is research that addresses vexing, really complex problems. And I'll just say the indoor air quality field is one that deals with really complex problems that have not been significantly studied. It's been a woefully underfunded and woefully understudied field for forever. And it's also a field where human behavior plays a huge role on the quality of one's environment. Many of the things that we do in our own lives, we make decisions that end up impacting us in terms of inhalation exposure of chemicals and and those types of things. One of the most rewarding experiences I've had is interdisciplinary experiences working with faculty in psychology at the University of Texas at Austin, where we actually did psychological typing of individuals, about 2,000 individuals, to look at their levels of neuroticism or levels of openness and all of these types of things, and then to superimpose on that the activities that they engage in their indoor environment that actually affects indoor air quality, and go into some of those environments and actually take measurements to see if it all bears out. So working across disciplines, understanding human behavior, everything from psychology to communication science. I think these are really important integrations that we need to make as engineers to better understand human beings, where they live, where they learn, where they work, what they do, to try to solve, complex problems. That's just one example in indoor air quality.
Thank you. Sybil, we haven't heard from you. Do you want to weigh in on this?
Yeah, I actually had a good answer for the previous question too, but
well, give us both of them.
I mean, not necessarily a good answer, but I'll tell you one thing I'm really concerned about is with engineers now is by the time they come in to college, they're eager, they want to do great things, they're super energetic. By the time they leave, a lot of them are robots who can just apply equations. And so for me, trying to have them to think sincerely and fundamentally about their social and ethical implications in their work is super important. And so what I'm trying to do is, again, not being an expert in the field, is to have them talk, to have really them talk and share, and especially because at UIC, it's a very, very diverse population. So by having them just exchange and learning from their peers, I'm hoping it's having a positive impact on them. That's one of the things I'm doing, or I'm trying to do. And again, I'm a white male, so there's not much I can do. Plus, but that I mean, not the white male part, but the fact that I'm French, I think impacts on the second the second question, because I don't know if you know this about French people, but we always have to do something in a different way. If there's a way to do it, we're always going to find a different way to do it. We're always rebel. We're always against order. We always have to find something different. So here I know it's good to pick a field and to keep in it and not to be convergent, which means I am convergent all the time. So I go into philosophy, I'm an urban engineer. So I look at water, transport, wastewater, electricity, natural gas, telecom, all of them. Whenever I'm told that I should do it one way, I make sure to find another way to do it. So that's one of my strategies to be convergent, and that's just in the DNA of a French person. And you can ask any French people. We have an expression in French, which is the expression that proves the rule. Whenever there's a rule, a grammatical rule, there's always an exception, and so we always want to be the exception.
Absolutely, I know your country well, and you all very, very well. You're absolutely correct. I would like to throw a question out. I think they've been answered so far. I think Maya, Colleen, are there any other questions? Look like they've already given the answers to the questions I saw.
Yeah, we can still ask questions that were answered in the chat or the Q&A because people aren't always able to read or on YouTube Live. But we did have a pre-submitted question from Fernando Roman on Twitter. He said, what are some local methods to help remedy air pollution, especially in developing communities? So maybe Dr. Capps or Dr. Corsi.
Go ahead, Shannon.
That's a great question. So in developing communities, I guess I'm thinking I might address the urban side of that if you want to take the more rural side, Dr. Corsi. I think one of the main routes of exposure to outdoor air pollution is as people are indoors. And so some of the tactics that Dr. Corsi introduced can actually significantly help reduce exposure when one's home might be positioned beside an interstate where many of these nitrogen dioxide concentrations are high that have been attributed to increased incidence of asthma. So I think sometimes being fixed to a place might require interventions that just are adaptations, really, because the air pollution can't be controlled. But I think on a personal level, if one is choosing how they operate in that space, making choices to not burn fossil fuels, so either walking, biking, taking clean public transit routes, is one way to mitigate contributing to pollution in those locations. And then, choosing how your energy is produced, as we are able to do in Pennsylvania, might also be a way to reduce influences.
Okay.
So to follow up on what Shannon said, and this is a plug for the indoor air quality field, a shameless plug, is that, the vast majority of air pollution that we breathe during our lifetimes, we breathe indoors. And that's even true for pollution of outdoor origin. So making the indoor environment healthier by reducing pollution levels, even outdoor pollution, is important. We have a early career faculty member at Portland State University, Elliot Gall, who has done some great work with Portland Public Schools. And there's one school, Harriet Tubman Middle School, that's right along Interstate 5. I mean, literally, you could, any of us could throw a stone and hit the school building from Interstate 5. And Elliot worked with them for about a year and a half and worked with Portland Public Schools to put in probably one of the best filtration systems in any school in the United States, and did really extensive testing before and after. The benefit of that now in COVID times is that that school is probably the safest school in the United States with respect to protecting students from virus-laden particles, as one example. And Elliot put a lot of time into that, both funded and unfunded, to help that specific school.
Dr. Corsi, I would like to ask you or add to your conversation that just reminded me. You mentioned the mitigation of 2 ravages that this box fan was solving. Okay, you remember that?
Yes, I do.
Okay, you left out a very important third one. It's that you're putting people to work.
Yeah.
So you're stimulating economic development and bringing money into the economy at a time when resources are low. So, please add that one when you talk about the benefits of what you're doing, because you are bringing money into the community, and that is so very important.
Yeah, that's a fantastic point. Great point. Thank you.
Okay. Thank you. Colleen, we can take one more.
Yeah, there was a question submitted on Gmail to Dr. Hendricks about the participatory assessment technique, just asking for more detail what they were measuring and why on that slide.
Sure, yeah, happy to chime in. So essentially, really to sort of dovetail my response to address the convergence, because I think it's related to the development of this participatory assessment technique. I want to say quickly, when it comes to convergence, I think we have to, as scientists across different disciplines, we have to release our egos and understand that rocket science is rocket science, but most of what we all do isn't rocket science. And even within rocket science, I wouldn't underestimate the ability with, formidable training, not necessarily formal training, that folks can pick up concepts and contribute in ways that we may not have imagined. And I think that that's important in terms of releasing ego, creating space for folks to contribute, because as an urban planner, I deal in both physical and social science. But I have no formal training in engineering, although I took a few PhD level engineering courses during my doctoral program. But even within those classes with no prior formal training, I was able to contribute to the discourse and pick up on the concepts and keep pace with folks who have been in engineering spaces their entire lives or careers. And what I've found is that, community folks from the high school level up are really sort of, the same way in terms of being able to pick up concepts and contribute really meaningful thoughts and ideas with no formal training. And so, essentially what I did is, after taking a few infrastructure engineering courses during my doctoral program and learning the ways in which practicing engineers do visual inspections of infrastructure, I took that same survey instrument tool and slightly modified it for participatory and community application. And so we developed a set of performance standards where, on the survey, community scientists will respond in terms of pass or fail to these performance standards, which were essentially, descriptions of physical or visual quality of these different stormwater assets. And then obviously we have sort of an algorithm by which we calculated empirical scores ranging from 0 to 100, with 70 and above being passing and anything below 70 being failing. And so it was really just the same type of survey, visual inspection survey instruments that trained engineers use and practice for municipalities across the country, and just really with maybe just a mild amount of language, changes to the survey instrument, and then deploying it and handing it over to community scientists to do those same visual inspections.
Okay. Thank you. Well, I guess it's wonderful discussion, and I guess it's time to close, to call it to an end. Thank you so very much. And I just briefly, in closing, in addition to combating climate change, this pandemic has also highlighted the need for environmental engineers to rethink, reimagine, and drastically improve the quality and quantity of the delivery of sanitation services, and yes, I said sanitation services, to the most vulnerable populations worldwide. Access to safe, high quality, and abundant sanitation services will improve the ability for humans in carrying out normal bodily functions to slow the spread and remain healthy. Thank you. Colleen, you may take it away.
Thank you so much, Dr. Abram, for your wonderful moderating. We're so lucky to have you moderate this session, and thank you so much to our distinguished panelists as well for all their contributions. It's hard to believe this is the last session, but the work will continue afterwards through AWSP and everyone's research and teaching. So I'll just share some closing slides here. So please remember to take the session 6 quiz. And so it's the final quiz, and you can still take the previous quizzes. We'll keep it open for a couple weeks after this conference. Remember, you can earn a certificate if you score 80% or better for all the quizzes. And so this is a great opportunity for your resumes, for your CVs, and just your overall education. I hope you've learned a lot throughout this whole session. And just want to express my deepest condolences for anyone that is on this panel or attending, and in general to those who have lost family, friends, and loved ones due to COVID-19 and due to environmental pollution, waste, and climate change. Over 250,000 in the United States, 1.3 million throughout the world. Please stay safe and vigilant, especially those in the United States for the Thanksgiving holiday, and everyone for the holidays coming up in November and December. We hope that we can get through this, and we're, as environmental engineering and scientists, working diligently to help. And these flags representing each life in the United States do not reflect the disproportionate impact it has had on Black and Brown communities. And we're very sorry for your loss, and hopefully we can build back better and find solutions to mitigate future pandemics and the impacts of climate change. And we'd like to say thank you to all our sponsors and National Science Foundation for the funding to do this grant, and our institutions and AWSP. And we look forward to continuing this conversation even after this virtual series is over. And you can still watch asynchronously for anything you've missed or to rewatch if you want to. So thank you so much. And thank you for this opportunity to co-host this session. And thank you to Dr. Maya Trotz for all her leadership, and to all our organizers and the closed captioners and sign language interpreters.
And thank you. I enjoyed it.
Thank you.